Howdy, welcome. This is a video on indirect proof. This video is based on the textbook First Course of Mathematical Logic by Patrick Suppes and Shirley Hill. We're on section 3.7. Let's get started. An indirect proof is a proof by contradiction. We also call this a reductio ad absurdum, which means argument to absurdity. What's absurd is deriving a contradiction in the form P and not P. P is a case, and simultaneously, P is not the case. It's a contradiction, that's absurd. Now, by the way, we can make a distinction between the formal and informal sense of the term reductio ad absurdum. And in mathematical logic, we're only dealing with the formal sense, where we're deriving a literal contradiction, P and not P. But there's an informal sense of that term also. So we have the formal sense, which we're going to be using in mathematical logic, but there's also an informal sense. Now, in the informal sense, in informal logic, we're not necessarily deriving a contradiction. Rather, for example, we have, say, a set of premises, and this set of premises represents a worldview. We then logically derive validly an absurd conclusion based on those premises. It's not that the conclusion is necessarily contradictive, it's just that it's absurd in the more ordinary sense of the term absurd, being something that, so to speak, we intuitively see cannot be the case. So basically the idea is, here's a worldview, here are its premises, but those premises logically lead or entail this absurd conclusion that no one would accept. So therefore, because that conclusion is valid and is an absurd conclusion, there must be something wrong with that worldview. So that's the basic idea of the informal reductio ad absurdum. But here, we're only going to be dealing with the formal sense, where we're deriving a literal contradiction like P and not P. Now, aiding us in this indirect proof will be the conditional proof. And there'll be more details in the next slide. But let's just get the basic idea here to wet our feet in this. So if we can derive the conditional P implicates Q and not Q from a set of premises, we can know by modus tollens inference that P must be false because the consequent cannot be true, as it is a contradiction. We have Q and not Q after all. So basically, in a way, we can say we have this conditional, the consequent has to be wrong, so the antecedent is wrong. And we'll see what this all means in the next slide. Here's a textbook summary from page 137, direct quote. If a contradiction can be derived from a set of premises and the negation of S, then S can be derived from the set of premises alone. That is, if we have a set of premises, we make the assumption that S is not the case and are able to then derive a contradiction validly, it thereby follows that S is true, that S can be derived from the set of premises alone. In other words, if we have a consistent set of premises, and here I just mean the premises were given from the outset. They're consistent, they do not lead to any contradiction. And we then make the assumption of not S. We say not S is true, but here we do get a contradiction. This leads to a contradiction. It thereby follows that S can be derived as true. In that case, by the law of excluded middle, since not S cannot be true, S must be true. We have premises, we have the assumption not S, but this leads to a contradiction. But the only way that could happen is if not S is false. But if not S is false, S must be true. Likewise, if all the double negations confuse you, just think about it this way. If you can prove something to be true, it follows that it cannot be false. It's the same basic logic. Remember, contradictions cannot be true. In indirect proof, we're showing a contradiction. We're showing an absurdity. So here's the basic procedure for an indirect proof. Step 1. We will assume the negation of what you want to prove. We'll assume not S. Step 2. Attempt to derive a contradiction, such as Q and not Q. Step 3. We'll set up a conditional where our assumption not S, is the antecedent, and our derived contradiction, Q and not Q, is a consequent. Usually step 3 is not explicitly stated in a textbook. So when you're working on problems, you usually don't show this conditional proof aspect to the indirect proof. But in this slide, I want to show it because I think it helps to show what is actually taking place in an indirect proof. And you'll see what I mean even more clearly, I think, with an example. But basically, we have not S, and this we find out implies the contradiction Q and not Q. But this consequent here, Q and not Q, is a contradiction. It's logically impossible. It's logically false. So it thereby follows that the antecedent has got to be false. So not S is false, so S is true. If we look at our example, right here we have 3 premises, and we want to prove not P. I better write that down. So we're going to prove not P. So for sentence 4, what do? Step 1, we assume a negation of what we want to prove. We want to prove not P. The negation of that is P. And this is just an assumption. And as an assumption, we will quarantine it, so to speak, and put it in a box. If we assume P is the case, if we look at sentence 2, we find out that not R follows. So for sentence 5, we can say not R, because we have a modus ponens inference with sentences 2 and 4. This is based on an assumption, so it's in quarantine. And if we look at sentence 1, we have a disjunction. We have not Q or R, and R is not the case, so therefore not Q is the case, because we have a disjunctive syllogism with sentences 1 and 5. And now notice that sentence 3 says Q, but sentence 6 we have not Q. So for 7, we can say Q and not Q by the conjunction law with sentences 3 and 6. So we started off with the assumption of P. We ended up at Q and not Q. So for 8, outside the quarantine. And this is following step 3 here, which is usually not written out explicitly. We'll say if P, then Q and not Q, because we have a conditional proof with sentences 4 through 7. But because this consequent here is a contradiction, we know that P cannot be the case. And here we are using the indirect proof, and we're getting this from sentence 8. It depends on the textbook what abbreviations are used. I'll use IP. The textbook by Suppes and Hill uses RAA for reductio ad absurdum. Excuse me. Reductio ad absurdum. There we go. I had to pronounce it right. Okay, so we proved not P. Okay. Usually, as I said, this sentence 8 here is not included. Okay, so usually you go from sentence 7 to the sentence 9. But I included it in this case just to show you the underlying logic. We assume that P is the case, but that leads to a contradiction, so P cannot possibly be the case. So not P is true. We're going to work on 10 problems. We'll do 3 for this video and the remaining 7 for the next video. I should note that it's really not always clear when we should use an indirect proof versus a so-called direct proof. But as a rule, I think if there's no clear starting point to engage in a direct proof, then we should try an indirect proof. So if we have a set of premises and it doesn't look like we can directly infer anything from them, we should try an indirect proof. Just assume the opposite of what you want to prove and then try to derive a contradiction to thereby prove the contradictory of that assumption you made. Now let's try number 1. We want to prove that P is not the case, given 3 premises. I think a good first step is just to apply De Morgan on line 1. So let's do that. for line 4, we can then get not P or not Q by De Morgan, line 1. And then let's make our assumption for line 5. We want to prove not P. The opposite or contradictory of that is P. So let's just say P by assumption. And because it's an assumption, we have to place under quarantine. And then let's see what we can do based on that assumption. So line 2, we have a conditional if P then R. If we assume P, we can then get R through modus ponens. Hence for line 6, we'll say R by modus ponens 2, 5. Note line 3, we have a disjunction, Q or not R. Line 6, we have R. So let's double negate line 6. For 7, we can then get not R. Double negation, 6. And then we can do our disjunctive syllogism with line 3, Q or not R. And not R is not the case, so for 8, Q is the case by our disjunctive syllogism, lines 3 and 7. Line 4 is a disjunction, not P or not Q. And line 5 is P, and P contradicts not P, so let's double negate. So for 9, we can get not P, double negation, line 5. And then from line 4, we have not P or not Q. Well, not P is not the case according to line 9, so for 10, we can get not Q by our disjunctive syllogism with 4 and 9. And now we've ended up with not Q. Line 8 tells us that Q is the case, so let's just combine. For 11, Q and not Q, conjunction, 8 and 10. And we have ended up in a contradiction, Q and not Q, based on our assumption of P. So P must not be the case. So outside of quarantine, for line 12, we say therefore not P, not that assumption, by your indirect proof, lines 5 through 11. And that concludes that proof. And note that we just moved from 11 to 12. We didn't have to put a conditional there. So once we have our contradiction, such as Q and not Q, then outside of quarantine, we can just deny that assumption. It's not too bad. Number 2, we want to prove not T. 3 premises once again. And for the heck of it, I think we should do our indirect proof. And that's probably the only way we can prove this one. Although there may be another way, maybe with implications. Well, anyways, we got to do an indirect proof. So for line 4, let's assume T. So that is the opposite of not T. Line 1 is a conditional, if T then not S. So if we assume T, we can get not S through modus ponens. So for 5, we'll say not S, modus ponens, 1, 4. Look at line 2. We have if F, then not T. The consequent is not T. Here we have T. Those contradict each other. So let's double negate. We have to explicitly double negate. So for line 6, we can get not T, double negation of 4. And then we could deny the consequent to thereby deny the antecedent. So for 7, we can get not F by modus tollens, 2, 6. Look at line 3, we have a disjunction, S or F. Line 7, we have not F. And so for line 8, we can get S by disjunctive syllogism, 3, 7. Line 8, S. Line 5, not S. Let's combine. Line 9, S and not S, conjunction, 8, 5. And we have ended up at a contradiction, S and not S, based on an assumption of T. So outside of quarantine for line 10, we can therefore deny that assumption, not T, indirect proof, lines 4 through 9. For number 3, we want to prove R. We could do De Morgan right away, or we can just make our assumption. Let's just make our assumption this time. So for line 4, because we're going to do an indirect proof, we will assume not R, because that is the contradictory of R, it's the opposite of R. And then, still under quarantine, we could apply De Morgan on line 1. So for 5, we can get not P or not Q, De Morgan, line 1. Based on our assumption of not R, we can do a modus ponens for line 2. So for 6, we can get Q by modus ponens, 2, 4. Also notice, line 3, if not P, then R. So the consequent is R. Here we have not R. So through modus ponens, we can get not P. So for 7, we'll get not P, modus tollens, lines 3, 4, under quarantine. Line 5, we have not P or not Q. Here we have not P, so we have a disjunctive syllogism once again. So for 8, we can get not Q by our disjunctive syllogism with 5 and 7. So we have not Q, we have Q, combine them. Line 9, Q and not Q, conjunction, 6, 8. We've ended up at a contradiction based on our assumption of not R. So outside of quarantine, we can say that not R, we're denying that assumption, so not R. Indirect proof, lines 4 through 9. But not R is just R. So for 11, we can conclude that therefore R by our double negation of 10, and that concludes that proof. In the next video, we will complete exercise 12a.